Hello students, today we'll study module 4, that is time division switching. Time division switching. The first application of digital time division switching was to provide tandem switching of PCM junctions and trunk circuits. Since a tandem exchange is similar to the root switch in a local exchange, local systems were developed by adding read relay space division concentrators. Figure shows X local exchange. The development in the technology of solid state integrated circuits eventually solved the BORSCHT problem and enabled TDM concentrators to replace space division concentrators. This is evolution of integrated digital network. Finally, extension of digital transmission over customers' lines has enabled integrated service digital network. It provides the customer with a wide variety of services based on 64 kilobits per second digital transmissions over a single line from a local exchange. The architecture of a system X local exchange as shown in the figure. The digital switching subsystem correspond to the root switch of digital switch. The line terminating units of PCM junctions are connected to it directly. Voice frequency junctions are connected to it indirectly. Voice frequency junctions are connected via a signaling internetworking subsystem and an analog line terminating subsystems that provides analog or digital and digital or analog conversions. Analog and digital customers line are connected to the DSS via a concentrators known as digital subscribers. Switching subsystem, that is digital subscribers switching subsystem DSSS. These concentrators may be in the main exchange or located remotely. The processor utility subsystem uses software built largely from modules corresponding to the hardware subsystem that they control as shown in the figure. The system has a capacity of 60,000 lines and 10,000 furlongs of traffic. A tandem or trunk exchange uses a similar DSS but it has no concentrators. Space switches. Connections can be made between incoming and outgoing PCM highways by means of a cross point. However, different channels of an incoming PCM frame may need to be switched by different cross points in order to reach different destinations. The cross point is therefore a two-input AND gate. Thus, the switching network must be able to receive PCM samples from one time slot and retransmit them in a different time slot. This is known as time switching. So here you can see K incoming PCM highways and N outgoing PCM highways. A group of cross-point gates can be implemented as an integrated circuit, for example, by using a multiplexer chip. Figure shows a space switch with K incoming and M outgoing PCM highways, each carrying N channels. The connection store for each column of cross points is a memory with the address location of each time slot, which stores the number of cross points to be operated in that time slot. Time switches. So figure A shows time switch and figure B shows a space division equivalent. It connects incoming N-channel PCM highways to outgoing N-channel PCM highways. Since any incoming channels can be connected to any outgoing channels, it is equivalent to a space division cross-point matrix with N incoming and N outgoing trunks as shown in figure. Time slot interchange is carried out by means of two stores, each having a storage address for every channels of PCM frame. The speech store contains the data of each incoming time slot at corresponding address. Each address of the connection store corresponds to a time slot on the outgoing highways. Information is read into the speech store cyclically in synchronism with the incoming PCM systems. However, a random access readout is used. The connection store has cyclic readout, but writing is non-cyclic. To establish connection, the number x of time slot of an incoming channels is written into the connection store at the address corresponding to selected outgoing channel y. During the cyclic scan of speech store, the incoming PCM sample for channel x written into address x. During each cyclic scan of connection store, the number x readout at the beginning of the time slot y. This is decoded to select address x of speech store whose contents are read out and sent over the outgoing highways. Time switching networks. Space time space TSTS switching network. M is equal to number of PCM highways and N is equal to number of time slot. Each of M incoming PCM highways can be connected to K links by cross points in the A switch, and the other ends of the links are connected to M outgoing PCM highways by cross points in the C switch. Each link contains a time switch. To make the connection between the time slot x of an incoming highways and time slot y of an outgoing highways, it is necessary to select a link having a address x free in its speech store and address y free in its connection store. The time switch is then set to produce a shift from x to y. The connection is completed by operating the appropriate A switch cross point at time x and appropriate C switch cross point at time y in each frame. Next is time space time switch, that is TST switch. Time space time switching network. M is equal to number of PCM highways and N is equal to number of time slot. To make a connection between time slot x of an incoming highways and time slot y of an outgoing highways, it is necessary to choose a time slot z which is free. N the connection store of an incoming highway and the speech store of the outgoing highway. The connection is established by setting timer switch to shift from x to z, setting outgoing time switch to shift from z to y, and operating appropriate cross point at time z in each frame. Bidirectional path, you can see in the figure incoming trunk and outgoing trunk. Bidirectional transmission through time division switching network. The switching network STS and DST are unidirectional transmission. Since PCM transmission system use 4-wire circuits, it is necessary to provide separate paths for the send and the receive channels. One way is to provide separate switching network for each direction of transmission. However, this may be provided by connecting send highways of both incoming and outgoing circuit to one side of the switch and receive highways to other side of the switch as shown in the figure. In an STS network, the same speech store address in the time switch may be used for each direction of transmission. For a connection between time slot X on one trunk and channel Y on another for one direction of transmission, the contents at address are written at the end of the time slot X and at the beginning of the time slot Y. For the opposite direction of transmission, they are written at the end of the same time slot Y and read at the beginning of the next time slot X. In TSD network, speech in the two directions must be carried through space switch using different time slots. In order to specify through space switch, using different time slot for the two directions of transmission have a fixed time difference. Usually the time slots have phase difference of 180 degrees. In a 32 channel system, if the time slot 12 is used for one direction of transmission, then the time slot 12 plus 16 equals 20 is used for the reverse direction.